In this video, I'd like to give a mile-high overview of virtualization, and this is really for those of you who may not be familiar with it. And I should stress here that my purpose here isn't to give you a rigorous description of virtualization, but again, just more of a crash course to help you really set the stage for a subsequent discussion on security issues. And if you already are familiar with virtualization, you can feel free to skip this video entirely and dive right into the ones that I'm going to make on that actually discuss relevant security issues with virtualization. So imagine we have a physical computer, and I'm going to kind of diagram it as a big rectangle here. Got a physical computer, okay, and a physical computer at the lowest level will typically have a hardware level. So there'll be some hardware at the lowest level, and that might include things like let's say a CPU, a hard drive. In addition to that, may have networking, memory, and so on and so forth. Okay, now typically on top of the hardware on a computer, you have what's called an operating system or an OS. Okay, and these may be things like Linux or Windows or Mac OS and so on and so forth. And then really on top of the operating system, the level above it, and this is again a high-level overview, you might have an application running. So maybe there's an application that's running on top of the operating system. Okay, and this application is going to be utilizing a certain amount or certain number of system resources. It may utilize a certain amount of CPU, a certain amount of memory, a certain amount of hard drive space, etc. Now, oftentimes, and this is really maybe more so the case in business applications, and I guess you could also imagine it's in personal applications as well, but you'll often want to optimize how well you utilize the hardware that you actually have. Okay, you don't want to have an application that's only consuming 5% of the system resources, because if that's the case, then you're clearly not making the best use of all the money you spent on that underlying hardware, if that's all you're running on it. Now, on the other hand, if you tried, let's say, to have, I don't know, multiple applications, imagine you had a second application here, and you tried running many applications on an operating system, what might start to happen is that these applications, if you just kind of ran them blindly alongside each other, first of all, they may not be at all compatible with each other outright, and maybe in some cases they may be somewhat compatible, but there could be some weird situations that arise if these applications interact with each other. Maybe there'll be some, I guess, unexpected consequences and maybe unfortunate consequences of having these applications interfering with each other in perhaps unexpected ways, and that could certainly cause a new set of issues altogether. And of course, that's something you want to avoid. But at the same time, obviously from a cost and manageability perspective, you don't really want to have separate dedicated hardware instances for each single application you're running, because that could be way too expensive. And this is really where virtualization comes in. What virtualization allows you to do is effectively have multiple containers, if you will, kind of running on top of the operating system. So imagine you've got a container. And the idea is that in these different containers, you can have different applications running. Okay, so in these different containers can have different applications running. And each of these containers, in the context of virtualization, and when we talk about it, will have, basically they'll be running on top of the underlying operating system. And in this case, what we call the operating system underneath, we call it the host operating system, and I'll explain why we have to distinguish it. But we have the host operating system running underneath, and these containers are all running on top of the host operating system. And each of these containers will be an implementation in software of a physical machine. And the key word here is software. So they're basically software implementations of physical machines. And the way this is done in practice is through techniques like emulation. And there can actually be some level of hardware support to kind of enable the ability to actually virtualize. But ultimately, even the main thing to keep in mind is that from the inside, each virtual machine actually looks like a physical machine. In other words, this application will not realize it's running in software. Okay, it actually looks like it's running in hardware. And typically, the application itself, and in the context of virtualization, what you'll typically have is each virtual machine instance, and let me kind of make it bigger so you can see it more clearly, will typically have an operating system as well running in it. And so it looks like a physical machine, so it's going to have an operating system. And this operating system is called the the guest operating system. And in particular, um, uh, what I think is particularly amazing is that the guest operating system can be running something entirely different compared to the host. So for example, you could have a Fedora Linux guest instance running on top of a Windows 7 host. And obviously you'll have applications running on top of the guest OS. Okay, and these applications, this application thinks it's running on top of a dedicated piece of hardware. But in reality, it's not. It's actually running inside of a piece of software, which is itself running on top of, actually, I guess the app is running on top of software, which is a guest OS, and the guest OS is actually running on top of a host operating system, which itself is then executing on top of a piece of hardware. So I know it's kind of confusing when you think about all these layers, but hopefully it makes some sense. The idea is that you have these virtualized containers, okay? And then there's actually really an underlying piece of software which kind of acts as a layer between the operating system and all these virtual machines. And this is a layer that's called the hypervisor. And the hypervisor is really it's the piece of software, the underlying technology that actually sets up, instantiates, it manages all the virtual machines and so on and so forth. And this idea of virtualization and hypervisors and so on, it's actually an old idea. It was, I think, was first talked about, as far as I know, I think in the 1960s actually, by IBM. And so this is an idea that's age old, but a very powerful idea. And nowadays there are many technologies for doing this sort of thing. You have technologies like VMware, and Citrix has a technology called Zen. Microsoft has Virtual PC, and so on and so forth. But I think the main upshot and the main thing to keep in mind is that you now have one physical machine instance that's running multiple virtual machine instances. Okay, from the perspective of the applications running inside the virtual machine, they all think that they are running on a dedicated piece of hardware or a dedicated hardware instance, but in reality, they're not. They're running on software. And overall, I think that these virtual containers are more or less isolated from each other. And what that means is that an application, let's say you have this application running on this virtual machine, it's not going to interfere with this other application here running on this other virtual machine instance. Even though they're running on the same physical machine, they both think they're running on their own dedicated hardware. They actually don't interfere with each other. Okay, they're more or less isolated from each other. And what that means is that there's not going to be any unintentional interference that you wouldn't expect. It's as if they're running on their own different machines. And so as a result of all this, as a result of this approach and this architecture, you start to see things like CPU utilization improve. So CPU utilization will improve. You also get, to some degree, better manageability. And by that I mean that typically in the past, if you wanted to do something like this and you didn't have virtualization, you might have had to invest in many pieces of hardware. You might have needed, let's say you had these 3 applications, you might have needed 3 physical pieces of hardware, which means that those would have to be managed. Now you can have one piece of hardware, so you have one less physical device to manage, but now you have these 3 virtual instances to manage. All right, and the nice thing is that obviously in addition to CPU utilization, you can also manage not just CPU improves, but also memory can be better utilized, hard drive, etc., and networks, and so on and so forth. So the nice thing is that you get kind of better overall resource utilization from an approach that involves virtualization. All right, hopefully that gives you somewhat of a flavor of virtualization. Again, this was meant to be a crash course, a mile-high overview, if you will. And in subsequent videos, I'll talk specifically about the security ramifications of these types of virtualized environments.